Yeah, welcome to 04. Today we're going to be talking about counting techniques. Here's all of our vocab for this section. Make sure you get all these written down if you need to. Okay, the first one we've got is an outcome. An outcome is the result of a single trial of a process involving chance. So if you're flipping a coin, an outcome would be landing heads or landing tails, something along those lines. So basically, what could happen if you do something involving probability. We have a probability experiment. That is the process involving chance. So if you're flipping a coin, that's the experiment, is the actual flip. We've got our sample space as a set of all possible outcomes of a probability experiment. So again, if we bring back that coin flipping, our sample space would either be heads or tails, because that is everything that could possibly happen when you flip a coin. A tree diagram is used to systematically list the outcomes in a sample space, and it's a diagram and it looks kind of like a tree, and we'll talk about those in a little bit. The fundamental counting principle is the process for finding the total number of possible outcomes in a sample space. So how many ways could something happen when we do this probability? A permutation is an arrangement of a group of distinct objects in a certain order. So how many ways could so many objects be chosen out of the whole group? We're going to talk a little bit about n factorial, which is n with the exclamation point. And that is the product of every number between n and 1. So if we have 5 factorial, we would do 1 times 2 times 3 times 4 times 5. That would be 5 factorial. And a combination is a selection of distinct objects in which the order of the objects does not matter. So that's going to be the big difference between permutation and combination, is that in permutation, the order matters because it's a certain order. Combination, the order does not matter. So the first thing we're going to talk about is the fundamental counting principle. So basically, if we've got two events, event M and event N, and event M can occur in M number of ways, and event N can occur in N number of ways, then the event M followed by the event N can occur M times N ways. So basically, the number of ways the first event can happen times the number of ways that the second one can happen. So if you are going to flip a coin and roll a die, a normal 6-sided die, to be more specific. Okay. The number of outcomes that we could have is, well, there's two things that could happen when you flip a coin, 6 things that could happen when you roll a 6-sided die, so it would be 2 times 6, or 12. 12 outcomes could happen. So here's an example that I'm going to want you to work on your own, but I'm going to read it since my handwriting is atrocious. Okay, so the question is, how many ways to make an ice cream cone? If you can choose between 3 different cones, 4 different flavors of ice cream, and 2 different toppings. So again, your job is to figure out how many different combinations we could have. So go ahead and pause the video, use that fundamental counting principle to figure out the answer, and then go ahead and hit play and see how you did. Okay, since we had 3 different cones, 4 different flavors of ice cream, and 2 different toppings, we multiply all of those together to get a grand total of 24 different combinations that we could make. The next thing we're going to do is we're going to start talking about permutations of n objects. So to start out with, if we have a certain number of objects and we're going to take all of them and put them in order, we're going to use n factorial, or the product of all the numbers between 1 and n. So an example of that is if you're on a baseball team or a softball team, you have 9 players, and you want to know how many different batting orders we can make. Okay, so obviously all 9 batters are going to bat, so we would do 9 factorial. And so we would do 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9. And we would get an answer of 362,880. Now, if you're one of those people that have the 83 or 84, like I suggested at the beginning of the year, there's a way to do factorial on your calculator. So the first thing you would do after you've turned your calculator on is you would type in your value for n. Okay, in the last example, we would have pressed 9. Then we would have hit the math button that's located towards the top left of our keyboard. Okay. Once we hit that button, we go to the probability tab. They label it as PRB. That's on the far right of that menu. And once we get there, we would select option 4, which is the exclamation point, and we would press enter. And then that would do it for us, so we wouldn't have to type out all of the numbers between 1 and 9. The next thing we're going to talk about is what happens if we don't want all of them to be used in the group. So what if we have a bigger group and we want to choose a smaller number of them and put them in a certain order? Okay, so that would be a permutation of the total number of objects, or n, and we're going to take them r at a time, whatever that smaller number is. So to find that, we use this formula right here. So we take the number of total objects on the top, we use factorial, and then on the bottom we take the total number minus the number that we want, factorial. So this is an example of what that would look like. We have 5 students to choose from, and we want to choose a president, a VP, and a secretary. So we're only choosing 3 out of the 5. So this would be a 5 pick 3. So we've got 5 of them and we want to choose 3 of them. Now the reason why this is a permutation is because it matters the order that they're picked. If a student is picked as president, that is a lot different than if they're picked as a VP or a secretary. So what we would do is we'd have the total factorial on the top, and on the bottom we would do total minus the number that we're picking, factorial. So really, we would have 5 factorial over 2 factorial. 5 factorial is 120. 2 factorial is 2. 120 divided by 2 is 60. So there would be 60 different ways to choose a president, a VP, and a secretary out of 5 students. Once again, those with an 83 or an 84 have a little bit of advantage because permutations can also be done on the calculator so that we don't have to type in all of that stuff. So if we wanted to do the 5 pick 3 as we did on the last slide, the first thing we do on our calculator is we'd hit the n, so we'd press 5. We would hit the math button again in the top left. We'd go all the way to the right to that probability tab. This time we would select option 2, which looks like this, NPR. So we would press that. And then we would type in our R. So in that last example, we would type in a 3. And then we would hit enter. So again, we would hit 5 here for our last example. Go to math, probability, select option 2. We'd type in our R, so how many we're choosing, that 3. And we'd hit enter, and we'd get 60, just like that. So when we want to do a permutation, that means that the order that we're choosing them matters. Now, combinations are the opposite. So we've got a certain number of objects, and again, we're going to choose a smaller amount of them, but this time it doesn't matter the order that we pick them in. So how we do that is this equation right here. We still have the total number of objects factorial on the top, but now we also have this n minus r factorial that we had on permutations. The new part is that we're also going to do the number of objects that we're picking factorial as well on the bottom. An example of combination would look like this. So we've still got the 5 total students that we're choosing from. We're still choosing 3, but this time we're just gonna make a committee of 3. There's not gonna be any titles associated with any of the positions. So now it doesn't matter when they're chosen, it just matters that they're chosen. So we would still have the 5, that now it's gonna turn into a C, because it's combination. On the top, we're gonna have 5 factorial. On the bottom, the number we're choosing factorial times the total minus the number of choosing factorial. So we're gonna have 5 factorial over 3 factorial times 2 factorial. Now from the last one, we know that 5 factorial is 120, and we also know that 2 factorial is 2. 3 factorial, or 1 times 2 times 3, is 6. So on the bottom, I'm going to have 6 times 2, which gets me 12, which means that of the 5 students, there's only 10 different committees of 3 that we can choose. You'll notice that combination has a lot less choices than permutation. Once again, on the 83 or 84, there is a way to do this, so you don't have to type in all of that factorial stuff and multiply it together. So again, you'd start off by typing in your n. In our last example, that was a 5. We still hit math, we still go to the probability tab, but now instead of selecting option 2, we select option 3, NCR. Once we've got that option selected, we type in our R value, which in this case was 3, and then we hit enter, and then that would give us our answer of 10. So once again, it's very important to figure out if the question is asking for a permutation or a combination. It won't just outright tell you permutation or combination. So when you're going through problems, you have to ask yourself, does the order of the picking matter? If it matters, it's a permutation. Now again, remember, with permutation, usually they have titles to each spot. Okay, like a first, second, third, or president, VP, secretary, or if they outright say order matters, okay, they might say that. Okay, that's for permutation. Otherwise, if it doesn't matter, then it's a combination. So a combination, there's no titles, no individual titles, that is. Okay, there won't be a first, second, third. There won't be a president, VP, secretary. They'll say choose a committee of 3 or something along those lines. Or they might just say order doesn't matter. Okay, so you have to be able to look at the question and figure out, are they asking one where the order is going to matter, or is it not going to matter? And then once you've figured out whether it's a permutation or a combination, then that's when you use the given formula.